All right, let's take a second, and before we really get into the notes on parallel and perpendicular lines, topic 8, I just quickly like to go through the beat the test question here. So we have a directed line segment, which means direction matters. We're going to move from A to Z, so starting at A, heading towards Z. Let's go ahead and plot those 2 points. A is located at -3, 1. And Z is located over at +3, 4. Go ahead and draw the segment. And what we're going to be doing is just moving fractional. Well, let's just see where these segments land, and then we'll talk about it. Let me use some different colors for them. So L is at -1, +2. So here is L. And M is at 0, 2.5, so there's M, and then N is going to be located at +1, 3. Let's see if yellow will show up. +1, 3. Here is N. Okay, so the question is, it's just a series of questions. The point blank, so what point partitions segment AZ into a 1-to-1 ratio? So that means if we put a point on this entire segment, it's splitting the segment up so that there's 1 equal part to the left of that point and 1 equal part to the right of that point. It's splitting it up into 2 equal pieces. And that's happening at M because M is smack in the middle. All right, so we have an equal amount of segment to the left and the right of M, 1-to-1. Which point is partitioning AZ into a 1-to-2 ratio? Meaning on the left side of that point, or on the A side of that point, is 1 portion, and on the Z side of the point happens to be 2 portions. Well, let's look at our overall move from A to Z first of all. Going from A to Z horizontally, it looks like we're going from -3 to +3, so we're moving 6. And vertically, we're going up 3. Well, to get to L, we went over 2, up 1. That puts me at L. What if I do that again? Over 2, up 1. Over 2, up 1. So moving from L, over 2, up 1, you can see we do that 3 times to make our way to Z. But looking at point L, I've got 1 equal portion on the A side of L and 2 equal portions on the Z side of L. So that's a 1-to-2 relationship, since we're talking about heading from A to Z. So that one is point L. So by default, you would think point N would be the last one, and let's talk about why it is indeed point N. Point N does partition that into a 2-to-1 relationship, because when we're looking at N, and I probably shouldn't made it yellow, sorry. Here's N. We have, let me look at my moving from L again. From A to L, it was over 2, up 1, over 2, up 1, over 2, up 1. You can see those stair steps. And with respect to N, we've got 2 of those stair steps on the left side of N and only 1 on the right. So notice that ratio was a 2-to-1. This is the A side of our ratio. This is the Z side of our ratio. All right, what is the ratio of AL to AZ? AL to AZ. Well, L and N split this segment up into thirds. We have a third, a third, and a third. So if I'm just comparing AL to the whole entire thing, the whole thing was 3 parts, right? AL was 1 part to the whole thing 3 parts. That's in a 1-to-3 ratio. This one was actually a part to whole relationship that we were looking at there. Okay, we're going to keep revisiting partitioning. All right, let's just review what we know. Well, we'll use what we know about lines we just reviewed to talk about parallel and perpendicular. First of all, notice that here we go. Finally, Geometry Nation has marked these lines parallel. So we can look at this thing and we know for sure they're running parallel. These lines are parallel. And the symbol used to indicate parallel lines is this one. We've seen it several times. These lines, you can see the little right angle box right there. It's kind of hard to tell what it is. These lines are perpendicular to each other. We know it for sure because of that marking, and the symbol to indicate perpendicular was the upside down capital T. Now they want us to use the slope formula, y sub 2 minus y sub 1. Remember, this is the change in our y is our vertical change or our rise. The change in our x is our horizontal change or our run. But I think I'm just gonna use rise and run and use the graphs up above. So they're asking us, what do we notice about the slopes of the parallel lines? Well, let's look at each of them. And remember, you just have to move between really good points on the line. And it looks like these are points that intersect at nice, neat grid marks. So these lines are leaning to the left. So reminder, that means they're going to have negative slopes. And it looks like we're going down 2 over 1, down 2 over 1. So line L sub 1 has a slope of negative, what did I say, down 2 over 1? It has a slope of negative 2. And line L sub 1 has a slope of negative 2. And line L sub 2, again, just pick some good points right on that line. And sure enough, it also looks like we're going down 2, left 1, down 2, left 1. It also has a slope of negative 2. So the parallel lines seem to have the same slopes. So the same thing, what do we notice about the slopes of our perpendicular lines? All right, well, let's start with L sub 3. Again, just picking some good points on the graph, maybe here to here to here. So on this graph, it looks like I'm going up 2 over 1, up 2 over 1. So line L sub 3 has a slope of 2 over 1, or just 2. We'll make it 2 over 1. And line L sub 4, again, picking some good points on the graph. It looks like we are going down 1, right 2, down 1, right 2, down. So our down movement is negative and we're going right in a positive direction. So it has a slope of negative 1 over positive 2. So look at those slopes. They're reciprocals of each other, right? Instead of 2 over 1, we flipped it and we made it 1 over 2. But they also have opposite signs. This one's positive and this one is negative. So we say that these slopes, the slopes are opposites, meaning one is positive and one is negative, and they're reciprocals of each other. So they're opposite reciprocals. All right, now if the lines are given in equation form instead of graph form, we just remember that if we can get the lines in this form, then that's our slope, and that's how we would see the slope as opposed to looking at the graphs themselves. So, indicate whether each pair of lines are parallel, perpendicular, or neither. Just the quickest of reminders, these are lines because x to the first power. Notice you don't see any x to the seconds. There are no exponents. That means these are linear and they're lines, and we should be able to write them in this form. Well, the first one is in slope-intercept form, and for this line, the slope is equal to positive 2. But this one is not. So I want to solve it for y. So the first thing we'll do is subtract our 5. So we get that 6x minus 5 is equal to 3y. Then we have to get y by itself and divide everything by 3. Well, 6x divided by 3 is going to give us a 2x. And 5 divided by 3, it doesn't go evenly. Let's just leave that as a minus 5 over 3. And that's equal to, we do have y. So this is now in y equals mx plus b form, where my m is 2. This line also had a slope of 2. So since the slopes are identical, these lines are definitely running parallel to each other. What about the next one? Neither one of these are in slope-intercept form. Let's get y alone. We're going to start by zeroing out the x term first. So we have a negative 5y equals negative 2x plus the 10 that was there, and then divide by negative 5. Now just be careful of your signs. we get that y equals a negative over a negative. We have positive 2/5 x, and then 10 is being divided by that -5, so that's a -2 or a -2. So this line has a slope of positive 2/5. Let's look at the other one. Solving for y. Subtracting 10x, we get that 4y equals -10x plus 20. Divide everything by 4. Everything's even here. So we get y equals, all right, 10/4. First of all, a negative over a positive is going to be negative. We're going to cut each of those in half, right? We'll have 5 halves. So we have 5 halves x plus 20/4. Well, 20 divided by 4 is 5. So remember, the number in the denominator of the fraction has to go into both of those. So look at our slopes. This one was a positive 2/5. This one is a negative 5 halves. One is positive, one is negative. So they're opposites in terms of signs, and they're flipped. They're reciprocals of each other. So since they're opposite reciprocals, these lines are going to be perpendicular to each other. That's an N, that's an R, okay? Perpendicular. All right, same thing, solving for y. Subtract 4x, and we get that 3y equals -4x plus 63. Divide everything by 3, and y is equal to, so I can't reduce that, the 4x over 3. We'll just leave that, it's negative though, -4/3 x, but 63 over 3 is going to be 21. On this one, if we subtract 12x, we have that -9y equals -12x plus 27. Divide everything through by the -9. So we get that y is equal to, a negative divided by a negative is a positive, and these are each divisible by 3. So let's reduce them. 3 goes into 12 4 times, 3 goes into 9 3 times, and we have, it's positive 4/3 x, and then 27 divided by -9 is a -3. So this slope is -4/3, and this one is +4/3. They are opposites, right? They have opposite signs, but they are not reciprocals. And the slopes are not identical because this one is negative and this one is positive. So these are actually neither. They're not exactly the same, nor are they opposite reciprocals. Okay, let's look at these two lines. So these are special cases. X equals 4. X equals 4 is just 1, 2, 3, 4. It's just the vertical line that passes through the x-axis. Y equals -2 is just the horizontal line that hits the y-axis at -2. It has a slope of 0, and that's where they meet. Well, when horizontal and vertical lines meet, they make right angles. So these are perpendicular. Okay, all right, come over here to the try it, and that's all there is to this lesson, I believe. Yes, okay, write each letter in the appropriate column. So x equals -5, well, we just saw that. X equals -5 is a vertical line, so wouldn't it be perpendicular to y equals 4 is a horizontal line? Those are going to make a right angle. That's going to go there. All right, come up with a line parallel to 3/5. Well, if it's parallel to 3/5, it would need to have a slope of 3/5. So do we see a line up here that has a slope of 3/5? Well, this one clearly doesn't, because this is in remember, this is in y equals mx plus b form. We can see the slope there. Doesn't that one look like it's going to be 3/5? Let's just quickly change it though. So the first thing we would do is move the 3x over. So we have -5y equals -3x minus 30. Everything's negative. So when we divide by the negative, everything will become positive. So we get that y is equal to, the negative divided by the negative is a positive, but I can't really do anything with that except write it as 3/5, and 30 divided by 5 is 6, and it's positive, but we get 3/5. So it's definitely C that's running parallel to that. Okay, we want a line that's perpendicular to this one. Let me come down here. Let's take that equation, the 4x plus 2y equals 12, and get y by itself. Put it in slope-intercept form. So 2y equals negative 4x plus 12, and then we'll cut everything in half. So y equals negative 2x plus 6. So the slope of this line is negative 2 over 1 if you want. We're trying to find something perpendicular to it. So this one's negative. The slope that we need to find is going to be positive, and we want the reciprocal. The reciprocal of 2 over 1 is 1 over 2. So this is what we are looking for, a line up here that has a slope of 1/2. Well, by default, we already know this one has a slope of negative 1/4. It's got to be D. But let's just quickly see why. If we solve for y up here, subtracting x, we get that negative 2y equals negative x minus 2. Again, nothing but negatives. So when we divide by negative 2, everything will become positive. So we get y equals, there's a 1 there, right? 1/2. 1/2 x, negative 2 divided by negative 2 is a positive 1. But sure enough, it has the slope of 1/2 that we were looking for. So once again, by default, hopefully this one is going to be B. We can see that this line has a slope of negative 1/4. We're looking for a line parallel to this one. Well, if it's parallel to this one, the slope has to be the same. So since this line has a slope of negative 1/4, when we rearrange this, let's just make doubly sure it should have a slope of negative 1/4 if we haven't made a mistake. So subtracting the 2x, 8y equals negative 2x plus 7, divide by 8, and we get that y equals, so this will negative over a positive, it will be negative, cut each of those in half, and we end up with 1/4 x plus 7 divided by 8, we could just leave that as 7/8. But sure enough, it has a slope of negative 1/4, just like that one. So parallel lines have the same slopes. Perpendicular lines have slopes that are opposite in sign and reciprocals of one another.